So we apply our first boundary condition. We see that at point A we have this hinge support. So at point A our deflection is 0. Reason is we have hinge support. So I can write at x is equal to 0, your ya is equal to 0. Now substituting this x is equal to 0 and y equal to 0 in this deflection equation, and considering the equation up to first partition, since the equation up to first partition is valid between point A and B, we have EI into YA, which is 0, is equal to, your VA is 9.64 kilonewton, so we have 9.64 into 0 cube upon 2 into 3 minus 2 into 0 to the power 4 upon 2 into 3 into 4 plus C1 into 0 plus C2. So upon solving this, we get the value of C2 as 0. Now let's find out your C1. Now applying the second boundary condition, now we see that at point D we have this roller support. So at point D your deflection will be 0 since it is a roller support and it does not move. So I can write at x is equal to 6 plus 3 plus 2, 11 meter, our YD is equal to 0. Now putting x is equal to 11 meter in deflection equation and considering equation up to third partition, since equation up to third partition is valid between point C and D, we have EI into YD, which is 0, is equal to VA is 9.64 into 11 cube by 2 into 3 minus 2 into 9 to the power 4 upon 2 into 3 into 4 plus C1 into 9 plus C2, which is 0, first partition, plus 2 into 11 minus 6 to the power 4 upon 2 into 3 into 4 minus 5 into 11 minus 9 cube upon 2 into 3, final partition. So we see that in this equation our only unknown is C1. So upon solving this, we get the value of C1 as minus 87.61. So now substituting the values of C1 and C2 in the slope and deflection equation and rewriting the equation, we have this slope and deflection equation. Our next step is to find out what is asked. So we first take a theta A. Now slope at A or theta A would be given by the slope equation. Now putting in the slope equation x equal to 0, since your point A is origin, and considering the slope equation up to first partition, since equation up to first partition is valid between point A and B, we have EI into dy by dx at point A or theta A is equal to 9.64 into 0 square by 2 minus 2 into 0 cube by 6 minus 87.61, first partition. So from this we get the value of dy by dx at point A or theta A is equal to minus 87.61 upon EI. So now upon substituting the value of EI, we have minus 87.61 upon, your E is 200 into 10 to the power 6 kilonewton per meter square and your I is 1 into 10 to the power minus 4. So this is equivalent to 200 into 10 to the power 2. Now this is equal to minus 4.3 into 10 to the power minus 3 radians. We see that slope at point A is negative slope. Next we find theta D. Now for theta D we put x is equal to 11 meter in slope equation and considering equation up to third partition, since equation up to third partition is valid between point C and D, we have EI into dy by dx at point D is equal to 9.64 into 11 square by 2 minus 2 into 11 cube by 6 minus 87.61, first partition, plus 2 into 11 minus 6 cube by 6, second partition, minus 5 into 11 minus 9 square by 2, third partition. So your dy by dx at d or theta d is equal to 83.61 upon EI. Upon substituting the value of EI, we have 83.61 upon 200 into 10 to the power 2, which is the product of EI. So we get the value of theta d as 4.1 into 10 to the power minus 3 radians. Now we see that slope at D is positive slope.